In this unit, we're going to take a look at the different sources of software. In other words, where we can get this software that we're going to implement in for a system. Now, with a course like this, sometimes people make the assumption that we're going to develop a system completely from scratch. And other people make the assumption that we're just going to put components together that we purchase off the shelf. And the reality is somewhere in the middle because we create our systems from lots of different sources. They don't necessarily all have to be developed in-house. They don't have to be necessarily all purchased from one huge vendor. In many cases, we can purchase components from different vendors and develop some of the components. So lots of different places that we can source our software. So in this slide deck, I'm going to talk about outsourcing as well as the 6 different sources of software that are discussed in the textbook. How to evaluate off-the-shelf software, make sure it's going to meet your needs, and explain the purpose of reuse and its role in software development. Which is reusing not just software, but also libraries and things like that. So historically, software development for a corporate information systems department was done primarily in-house back in the old days. So large companies would have a data processing department or something like that, and they were mostly responsible to develop the software for the organization. But now it involves the use of components from external resources more often than our own internal in-house application development. So much in-house application coding involves making the components work together. So as opposed in the old days when our primary focus was building a system from scratch, today, if we do have development in-house within an organization, a lot of times their focus is taking the best of breed solutions from other people and putting them together and integrating them and making them work within their own organization. So the 6 sources of software that I'll discuss are using information technology firms, packaged software provider, which is where you buy software off the shelf, vendors of enterprise-wide solution software like ERP, like SAP, something like that, cloud computing, which is becoming more and more common, and then we'll talk about open source software, and then finally traditional in-house development. So there are ways to evaluate software from all of these different sources to make sure it's going to meet your needs. So again, the sources of software, so they could come from information technology services firms, packaged software producers, ERP providers like SAP, cloud computing, open source software, and in-house developers. So let's talk about outsourcing first. So outsourcing is the practice of turning over responsibility of some or all of an organization's information systems, applications, and operations to an outside firm. So outsourcing is not where we just say, okay, we're going to pay somebody to develop this solution for us. It's where we say we're going to outsource this entire the entire process to someone else. We're just going to say, look, this is what we need. You guys just handle it. You take care of the whole thing. So that might be where you engage with somebody like Deloitte or, gosh, I can't remember the name of the other company. Begins with an A, but all these big IBM, those types of companies that specialize in bringing a complete solution to the table. Your book talks about one example with Shell Oil, who outsourced $3.2 billion in 2008. So they spent $3.2 billion in outsourcing. And some of the vendors they used were EDS, T-Systems, AT&T, IBM, and so forth. Oh, Accenture, that's the one I was thinking of. That's another big a big firm like Deloitte. Um, but in any event, $3.2 billion, that's a lot of money that they spent. So they basically took a large portion of their IT infrastructure and outsourced it to these third parties. So some of the reasons to outsource is it's a little bit more cost effective because you can take advantage of economies of scale. Economies of scale being that you can pool your resources with other organizations, and it's a little more efficient if you have a company that does IT, that's what they do, and lots of different companies are using that same company. You don't have to pay an expert in Active Directory, for example, just to manage your own network. That AD expert might have enough work to do 4 or 5 companies. So you can pay them one time for 4 or 5 different installations of a certain solution. So you can make up for a lack of in-house knowledge. You can outsource things that if you don't have that knowledge base in-house. I just used the example of Active Directory, which is a pretty complicated system for a network operating system, and in many cases, you have to pay a lot of money to have people that really know how to manage, implement, and design those types of systems. So if you can outsource that, you could make up for that lack of knowledge in-house without having to hire people that know that. You can also free up internal resources. You can reduce time to market for products or for solutions that you need. You can spin up much faster because they've already done this. They know how to do it, the outsourcing firm. You can increase process efficiencies. And system development is a non-core activity for the organization. In other words, if you work for an organization like Shell Oil's core their core purpose is sorry, my computer wants to restart. But anyway, the systems development. So, in like Shell Oil, for example, is not a software development firm. They are they're an oil company. So that's not their core activity. So that's why outsourcing IT services might be good for them. Of course, they wouldn't want to outsource, development of or finding, sites to drill for oil or something like that. That's their core business. That's what they do. If anything, they would want to consult on that type of thing. And of course, there's political reasons like labor disputes if you want to sidestep, hiring because of labor disputes or whatever. But sometimes you get into some of the business ethical decisions there, which we'll leave for someone else to discuss. So global outsourcing, some of the top outsourcing companies are India, China, Malaysia, according to the A.T. Kearney report in 2014. And the top 10 are in Asia, Latin America, Europe, and Africa. So some U.S. firms are switching to something called nearshoring, which is instead of outsourcing across, around the world, to India, for example, U.S.-based firms may outsource to, say, a company in Mexico or Chile or Argentina or something like that, where it's much closer to us in the same time zone as the U.S., but it's still far enough away that they can leverage the labor costs that are available in those locations. So that's where we're starting to see nearshoring. So some of the these are some of the sources of software for outsourcing, like IT services would be things like Accenture, IBM, Computer Sciences Corporation. Packaged software would be Intuit, Microsoft, Oracle, SAP, and we'll talk about some of these guys later on. And then the cloud computing providers like Amazon, Google, IBM, Microsoft, and then open source like SourceForge.net. Of course, there's no real central repository for open source, but we'll talk about that in a little bit. So information technology services firms help companies develop custom information systems for internal use. They develop, host, and run applications for their customers, and they can provide other services like management, accounting, auditing, and financial. So packaged software, on the other hand, this is where rather than having to pay to develop software or pay to develop some solution, you buy a solution that's already built for you. You don't have to do anything except make sure it's going to work for you. And one thing that students will often confuse here is that, well, if I'm buying packaged software, we don't need to do any systems analysts, right? We don't have to do any analysis and design. And that would be wrong. You still have to do all the analysis and design, even if you're using packaged software, because you have to verify and validate that the packaged software is going to meet the needs of the organization. And also, there's a lot of work and expense in putting in packaged software. Some large packaged software implementations are in the millions upon millions of dollars. For example, trying to think of a good example here, but in healthcare, I work mostly in healthcare, and in the UK, I believe they spent something like $12 billion on their electronic medical record system that's nationwide. $12 billion. That's a system. That's $12 billion. That's a heck of a lot of money to spend if you're not sure if it's going to work. So a lot of analysis has to go into that decision before you pull the trigger on something like that. So packaging, providing software could range from broad-based packages like general ledger, like accounting software and so forth, to niche packages. For example, daycare management, right? So you go to a restaurant. The restaurant might have a system that runs that restaurant. That's a niche package. It's something that's developed just for restaurants. Where on the other hand, something like QuickBooks, which is accounting software, would be useful for almost any business. You don't have to be a restaurant to use that. So packaged software can run the range of between these niche packages that are developed specifically for a specific industry, and it can be a very small niche, all the way up to the broad-based packages like something like QuickBooks, which is useful to everyone. They're typically prepackaged off the shelf, meaning that you buy them from the vendor. They're already built. They're ready to go. You don't have to do any custom development typically, although there may be some integration concerns depending on how you implement it. So the software runs on all sizes of computers, from microcomputers to large mainframes. Again, it's off the shelf. It's turnkey. That's another term for this, turnkey software. And when you hear that term, it means not customizable. That means you can't customize a lot of this prepackaged software. So I work in healthcare, and one of the big vendors that's well known for being turnkey is a company called Epic in the U.S. They're based out of, I believe they're based out of Minnesota, and they're one of the largest electronic medical record companies in the United States. And one of the interesting things about them that's different from most of the other electronic medical record companies is that you cannot customize their solution. If something works a certain way in their solution, then your hospital has to work that way. You can't tell Epic when you buy their solution, you can't say, well, our hospital works a little different than other hospitals and we need to modify the solution to work for us. They say, no, you have to modify the way your hospital works to work with our software. So it's important to be aware of that mindset. So off the shelf software at best will meet 70% of an organization's needs. And I would say that that can be paradoxical as well. So not only can off the shelf software sometimes not meet all of your needs, but get pretty close. So a lot of times people will buy off the shelf software and use it, even though it doesn't meet 100% of their needs. They may sacrifice that functionality for the convenience of buying off the shelf software. The flip side is sometimes off the shelf software has way more functionality than you need. For example, that example I just gave you with Epic, you might purchase Epic for a small hospital, and it's designed to run on an enterprise-wide hospital, but they might purchase it at a small hospital and not need even a fraction of the functionalities offered in that product. They may even not have some of the departments that it's designed to work for. They might not even have a pathology department, for example. So that's completely worthless to them. Some of that functionality. So sometimes you're paying for things that you're not even going to use with packaged software. So that's another thing to be aware of with packaged software. So here's an example of Microsoft Word, which is packaged software. Certainly not something that you or I would want to develop, right? If you worked for a company and they said, hey, we need something for creating documents, it would be kind of silly for us to go and develop our own solution. Let's just buy Microsoft Word. It already exists, right? It's probably going to meet most of our needs. This is probably a good example of one of those packaged software that meets more than your needs, right? A lot of us have Microsoft Word, and we don't even use a fraction of the functionality that comes with Microsoft Word. So another source of software is ERP, or Enterprise Resource Planning Systems. These are integrated packages that run an entire business. SAP is the leading vendor of ERP system. They're the largest company that offers ERP. So ERP basically does everything: supply chain management, manufacturing management, human resources, all the stuff that you need to do in a big multinational company. SAP can hopefully do for you, and it's an alternative to building your own solution. Cloud computing is another source of software in the sense that cloud does a couple things for us. It allows us to host applications and services on someone else's computer, right? That's really what the cloud is. It's someone else's computer. And it also allows us to use someone else's infrastructure. So, one example that would be considered cloud is your email. Most of you probably have email, and you probably don't have your own email server. You probably use something like Google Apps, for example, which has Gmail. In some areas, you might not be able to use Gmail, and they might have some other, for example, in China, I've seen a lot of people have QQ email addresses, which might be a different service, very similar. But again, it's somebody else's computer, it's someone else's service. You sign up and you use that service. So that would be something like Google Apps. Salesforce.com is another example. That's a CRM solution or a customer relationship management solution, which is hosted in the cloud. So somebody else owns it, and you just pay to use it. Microsoft Azure is a platform that you can use to host databases. Active Directory, which I talked about earlier a little bit. You can host your infrastructure storage. You can put computers in Azure, the whole thing. Amazon lets you do exactly the same thing, as well as Google. Google also has a cloud platform. So Microsoft, Azure, Amazon, and Google are probably the three biggest cloud platforms right now where you can outsource your infrastructure. One thing I should warn you about cloud computing is that it is billed based on usage. So, it's kind of like your electric bill. You pay for what you use. And if you leave the air conditioning on all day and leave the windows open, your bill is going to be enormous. Same thing, you can do something similar. You can with Microsoft Azure or Google or Amazon. You can leave the windows open and leave the air conditioning running and air conditioning, the whole world if you wanted to, and just pay for all of that electricity. Same thing with Amazon and Google and Azure. You might have a coding error that causes some kind of memory leak in a computer that's in the cloud, and because you're paying for that computational time, it's just going to use as much as it can and just blow up your bill, right? So certainly something to be aware of. But cloud computing has become is becoming rather ubiquitous at this point. A lot of folks are moving towards cloud computing because it frees the company of internal IT staff requirements. You're leveraging that economy of scale that we talked about with outsourcing. You have faster access to applications than via internal development. It has a lower cost than internal development, but some of the concerns are security because somebody else owns your data, somebody else is hosting all that data. You really don't have much control. You have reliability. Again, you don't have control over the reliability. Somebody else is handling all that stuff. So if Azure goes down, you're down. If Amazon goes down, then you're down, right? And that happens sometimes. We hear those stories about these big cloud providers occasionally going down. And then there's also regulatory compliance. For example, if you're a government organization, you may not be able to use the cloud unless you meet strict regulatory compliance. And some of the cloud providers are starting to do that. Um, but with financial and healthcare and things like that, there's lots of regulatory requirements. You have private information about your customers that might be in the cloud. They might have to consent to that data being there. So lots of concerns like that we have to think about. And then we have open source software, which is freely available a source that you can download and install and use for free. And when I say free, it's free as in free beer, not free as in, I'm sorry, free as in freedom, not free as in free beer. When we say free beer, that means you get something for free, but you don't necessarily have complete control over it. Where with freedom, you have complete control, but it doesn't necessarily have to be free either. So for example, MySQL, which you can see on the screen here, is an open source database engine. It's actually owned by Oracle, but they made it open source. They actually purchased it after it was open source. But you can download and use MySQL for free. It's a really powerful database engine. So how does Oracle make money with that? Well, they sell support. They sell commercial versions of it. If you have a problem with it and you want support, you can pay for that. So there is a revenue stream with open source software. And that's how they make money. They provide maintenance and support and services and sometimes consulting for their products or for those open source software. And sometimes they just sell a more featured version of the free software. Open source is not free as in it doesn't cost anything, because you do have to pay for open source software in the sense that you'll probably have to pay for support. You have to pay for someone who knows how to operate it and how to install it and how to configure it. So there are hidden costs there sometimes that have to be concerned or have to be considered. And in some cases, some people find that open source ends up being more expensive than buying commercial software. So there's that as well. But I'm certainly a big advocate for open source when possible. If there's a solution that's open source that's well understood and it's a powerful solution, then by all means. Linux, for example, is one of the best operating systems in the world, and it's free and open source, and anybody can download it and use it. A huge portion of the web properties in the world are running on Linux, so it's certainly a pretty popular platform and very well used. And then finally, we have the good old-fashioned traditional in-house system development. So this is where we do everything internally. So it usually leads to more maintenance burden than other approaches because pretty much everything relies on our internal staff. So here's all the different sources of software and a quick comparison of those, and you're welcome to pause the video and you can take a look at those in more detail if you like, although they're also in the textbook. So if you're going to select off-the-shelf software or any type of software that you're going to use in the environment, you want to consider the cost. So you're going to compare the cost of developing the same system in-house with the cost of purchasing or licensing a software package. And when you're doing that cost analysis, you're looking at all the costs, not just the initial cost of the software. You're looking at maintenance, the people that you have to hire that understand that software and so forth. And we'll talk about that later on when we look at feasibility analysis with project selection. The functionality is the task that the software that it can perform, the mandatory, essential, and desired features that you need. What are the deal breakers? Is there vendor support? So will they support it? And at what cost will they support it? What's the viability of the vendor? What if you buy this solution from a small company and they go out of business next week? Now you spent $10,000 on this solution and no one to support it because they're gone, right? And you have to go right back to the drawing board. Those types of things happen. Flexibility, the ease with which the software can be customized to meet your needs. Does it have adequate documentation, user manuals, technical documentation? That's important because if you don't have ownership of that software, you're going to need the documentation to understand how to use it. The response time, how long does it take the software package to respond to the user's request in an interactive session? What's the latency? The level of usability and so forth. And of course, the installation. How difficult is it to implement this particular software? So one of the ways we can determine all of that stuff is by using an RFP, which is a request for proposal. So we basically figure out, what do we need this system to do? How does it need to work? What are the features that we require in our organization for this to work for us? You take all of that information and you codify that into a request for proposal, and you say, here's all the stuff we need, and you send it to all the vendors you're interested in, and then they're going to come back and they're going to say, here's all the things that we can do for you, and here's how much we're going to charge in order to do that. Now they may put things on that RFP that they can't do. They might say, well, you want this, but we can't do it. And they'll put that on there. They'll say, we can't do this. Or they might say, we can do this other thing. We could do these additional things. And you have to kind of take all of that into account. So you can't just assume because someone responds to your RFP, they can do everything that's in your RFP. You have to actually read the RFP and validate that everything that they said, and then you have to put that into some kind of decision matrix to decide which is your best option from the RFP. What's interesting about the RFP is in a lot of cases they sort of become a legal document that the vendor has certified that these are the things that I can support. So if you end up using that vendor for whatever they responded to the RFP, you know that they're going to be able to do all that stuff. And if they can't do anything that they told you they could do, you could go back to that document and say, you told us in the RFP that you had this ability. It's written right here, but now you're telling us that you can't do that for whatever reason. And you could have, you could seek some sort of compensation for that. Sometimes RFPs are called the request for quote, or an RFQ. So you'll see that term as well. So analyst selects the best candidate based on the bid, how much money it's going to cost, a variety of other sources. They could call people for references, and also do a matrix of all the functionality. Look for any deal breakers. What functionality do they not support that you're going to need? So those types of things we would take a look at in an RFP and make that decision. Now, one thing I should say is, where do we get this information to create this RFP? How do we know what we need? Well, that's going to be the analysis. So in this course, we learn about analysis and we learn about design. If we do our analysis and design, we can use that to create the RFP. So some organizations go backwards. They put out an RFP hoping to get a response that says, here's what we can do for you, without going through the systems analysis and design process. And then they're going to get something that maybe meets their needs, but maybe doesn't, because they don't even know what their real needs are, right? They haven't done the analysis to know exactly what they need. So the right way to do an RFP is to start with the analysis and design that we talk about in this course, that we're going to talk about in later units in this course, and use that to write the RFP, because then you're basically designing a system and asking other people if they already have something or if they can give you something that's going to meet your needs instead of developing it in-house. And you can take their responses and compare it to what you could do in-house or what you could outsource. So you could look at all these different options instead of just getting off the source software. So your textbook talks about some people use vendor proposals to get this information. They could use a series of tests, feedback from other users, independent software testing services, customer surveys, calling and getting references and things like that. So finally, in this unit, we talk about reuse, which is, there's two things that we talk about with reuse. Number one is, do we have other components in software that we can use, that we already own, that's already implemented, that we can extend to the solution for which we're trying to design? And also, when we are designing a system and doing analysis and design, we want to try to pick a solution or move towards a solution that lends itself to reuse. In other words, we're going to be able to leverage this solution for other things in addition to whatever it is that we're designing. This is a common concept in object-oriented development and component-based development. So in object-oriented, you use these classes and objects. We're going to talk about this in much more detail later on, but it lends itself well to reuse in the future. So some of the technical issues with reuse is a lack of methodology for component library, so creating and labeling reusable components. And then organizational issues where it's hard to share all of these different components. You may not even know what's available from other divisions or departments or from other projects. These could be in little walled gardens that you're not even aware of. So your book talks a lot about that as well. So there are three steps. There's abstraction, storage, and recontextualization. So abstraction is the design of the reusable piece of software. Storage is how you can make this reusable components available to other people in the organization. And recontextualization is a fancy way of saying making sure that you have documentation and that the structure of the program and the components is in such a way that it's easy enough for somebody else to reuse. So, a lot of times when we get projects in IT and we look at what somebody else did, it's so complicated that by the time we decompose what they've done and figure out exactly how it works, by the time we do all that, we could have just built our own system, right? And that's what they're talking about with recontextualization. So some approaches are the ad hoc approach where individuals just kind of do this on their own. You can have facilitated where you encourage reuse, you encourage the practice of recontextualization, for example, and then managed where the development, sharing, and adoption of reusable assets is mandated by the organization. So those are some different ways that we can approach this. All right, so that is pretty much everything you need to know about the sources of software. And in the next couple slide decks, we're going to start getting into project management and project planning and planning our new system and selecting the right project. So we're going to kind of go through that planning phase of the systems analysis and design. So we're going to talk about all of the risks that we might see. We're going to see how to evaluate some of those risks and so forth and so on.